Let's do number 1. That's probably the one that gave you the least trouble. Right? So G prime. So we're looking at... Okay. So we're looking at the derivative of the natural log, right? So the derivative of natural log of u is 1 over u du. Okay? So we're going to do 1 over x cubed minus 2x, right? This is the natural log of u, right? Times the derivative of u, which is 3x squared minus 2. So we're going to get 3x squared minus 2 over x cubed minus 2x. Yes, ma'am.
Would it be to the negative 1? Because if you do the outside, then you have to subtract 1 from the outside as well. So like the exponent.
No, that's where, remember how we said before, sometimes you really need to use the u substitution? This is one of those cases. We're taking the derivative of the natural log of u, and u is x cubed minus 2x. The derivative of the natural log of u is 1 over u times du. So 1 over u would be 1 over x cubed minus 2x. And then the derivative of that is the 3x squared minus 2. So this is one of those cases where trying to do the outside inside instead of u substitution can be very confusing. Okay? So that's your answer right there. Everybody okay with that? Okay. Let's look at the next one. So this one, you will see this. I don't want to say guaranteed, but I'm pretty confident that you will see something like this on your exam, because this is just a lot of the multiple choice questions. They'll give you something like this because for some reason, they think it's so important that you recognize the actual definition written out like this. This is technically the definition of the chain rule, right? Chain rule is used when we have a function composition, f of g of x. So if we're taking the derivative of f of g of x, that's when we do the chain rule, when it's a function composition. So this one up here, this is a function composition. So like if f of x is natural log of u and g of x is x cubed minus 2x, I'm sorry, this should be x, not u, right? Then f of g of x, right, that's f of x cubed minus 2x, which is natural log of x cubed minus 2x, okay? Anytime we're using the chain rule, we're doing so because it's a function composition. So we have to recognize that this is chain rule, which is outside inside. The outside would be f prime of g of x. That's the outside. The inside is g prime of x. I would be surprised if we did not see some of this on your exam in the form of multiple choice. Yes.
Will I have like a table like that above it?
Maybe.
Kind of confusing.
Maybe. So we didn't finish yet. So it could be that they just have it like this, or we might have a table. Now we can go in and fill in the information. What am I taking f prime of? G of x. Okay. Oh, did I not give you any other information?
No, we didn't have to.
That's why I came up to
Oh.
She's like, yeah, do the chain roll. You can't do the chain roll about a number.
That has to be either 2 or 3.
Okay, then we're just going to leave it like that then. We'll just we'll use the table for the bottom part.
Word.
Okay.
Wait, if you were using
So what if it was derivative of f of g of 2 with respect to x, right? So now we've got, so this is going to be f prime of g of 2 times g prime of 2, right? So that's f prime of g of 2, which is 3 times g prime of 2, which is negative 2. F prime of 3 is 2 pi times negative 2, so we get negative 4 pi. Okay?
You guys write that down.
No, you don't have to. Okay, let's look at the next one. All right, so let's see. We're taking h prime. So with these types of problems, I have given you these types of problems to practice because when we had a test on this unit, it was clear to me that you were struggling with this type of problem. Okay? So what we have to do is we have to take the derivative, and we're just using a formula. Then we're going to substitute in the values afterwards. Okay, so this is an outside-inside. So it's going to be 2/3 for f of x plus g of x, right? I'm just using the formula. Now we're going to do this minus 1, so it's negative 1/3. That's the outside. Now we're going to take the derivative of the inside. So that will be 4 f prime of x. I don't know what f of x is, so I don't know what f prime of x is. So I'm just writing it as f prime of x. Plus the derivative of g of x, so we just write that as g prime of x. So we have outside, inside. Now let's substitute some values in there. This is where x is equal to 3. So we've got 2/3, 4 times f of 3, which is, f of 3 is 2, okay, plus g of 3, which is negative 4 to the negative 1/3, times 4 times f prime of 3, which is 2 pi, plus g prime of 3, which is 5. Are you with me so far? Okay. So we have 2/3 times, let's see, 8 minus 4, so that's 4 to the negative 1/3. And that's just going to be 8 pi plus 5. Hello? What you got?
For next period.
Oh, perfect. Thank you very much. Okay. Thank you. Bye-bye. Okay, so let's see. So, of course, this is not going to be nice. We won't want to be too nice about this, right? Okay, so let's see. That's 2/3 times 1/4. So I'm going to write 1/2 squared to the 1/3, right? Because it's a negative exponent, I moved it down and it becomes a positive exponent. Okay. Times 8 pi plus 5. Does everyone understand how I moved the exponent and why I did? Okay, I changed. I'm sorry.
Why would you have to change it to the 2 squared? Because either way, you realize you're not gonna. Isn't it easier to just leave it as like a radical, so you can just keep like the fraction?
Yeah, I just instinctively changed it because of this 2 here. Right, so I'm going to have 2/3 times 1/2 to the 2/3 times 8 pi plus 5, right? So this is 2 to the 3/3. So yeah, actually we should be able to simplify this. So this becomes 2 to the 3/3 over 3 times 2 to the 2/3 times 8 pi plus 5. So 3/3 minus 2/3, so I get 2 to the 1/3 over 3 times 8 pi plus 5. And I'm going to leave my answer like that.
Where's 3/3 coming from?
This is just 2, and 2 to the first is, I can write it as 3/3 because I have to subtract those exponents. So I want a common denominator. Okay. So that's our final answer. Okay. Okay. So I have a couple policy adjustments for this semester. First one is the cell phones need to be in that cell phone spot. Okay, you guys know this. This is not a surprise to you. I should not have to be barking at the door saying, cell phones in the spot. I shouldn't have to be doing that. Okay. It's been a year and a half now that we've been doing this. So you know this. It is your responsibility to put them there. If they're not there, I'm going to write you up. Okay? They need to be there. Secondly, for now, I'm going to allow you to continue having your iPads out because I know a lot of you, that's where you take your notes and you do a beautiful job. But if I continue to observe that people are watching videos and doing other homework on it, then I'm going to take that away from you. Okay, because I know that some of you are doing that. Okay. Homework. Homework will always be due at 8 a.m. the day you're on your due date. So homework given today will be due at 8 a.m. on Thursday, because I do not have you Wednesday. So homework given today will be due at 8 a.m. on Thursday. That way we will be ready to go when we start class. Okay, one of the things when I was videotaping my classes before Christmas, one of the things I noticed is that I'm taking too long to get started. Many times it's my fault, but many times it's because I'm waiting for the students to get ready. Okay, and that some of you are you're uploading your homework, you're going and borrowing a calculator, you're getting pencils, whatever. Okay, so we need to be ready to go because we can't afford that loss of time. And this class it hasn't been too bad, but like in my Algebra 2 class, sometimes it was 10 minutes before we got started. Okay, and that's just, we can't afford that kind of time. And I need to do a better job of making sure that we get started. Yeah.
I don't know overpass from last semester. I think it said that it like expires in December.
Uh-huh.
Is it okay if I use it for this semester?
No, it expired in December.
Silly
Should have
shoes.
crossed that part out.
We shouldn't have asked that question.
Well,
You know, you just read it out the rest of the time.
pretty sure I would have noticed it.
I think it says it. Let me check.
No, I was just saying, like, if it expires in December, you can't use it.
Yeah.
You gotta go into Publix and ask if the food box still works after.
Oh.
Oh, come on, Caitlin.
I didn't use it. Oh, I did mine.
I'm sorry. Okay, so let me see. What I talk about? Cell phones, iPads, due dates on homework. Yes.
The due dates on homework, they're the next time we have class? Or
Next time we have class and at 8 a.m. Right. Okay. Okay. And we will have more cumulative quizzes and tests. So, like if we have a test on, I'm on some spam list and it's driving me nuts. Driving me nuts, calling me all day long, wanting me to contribute to the fireman's thing and the police thing, and oh my goodness.
Are you sure you don't want to extend your car?
Yeah, that too. Yeah. Cumulative. So that means like if we have a test, we're going to have a test on Friday on implicit differentiation. You may see something from previous material that we've done, like something like what we just went over. And the reason for this is that we need to be remembering what we've done before because we have a big exam in May, and we need to remember the old stuff. Okay. So this is crunch time.
Like just a random one like this.
Yeah.
But only be like one or two, not like.
Now, the majority of the quiz or test will be on the current material, but there will be some random questions from before. Might be limit questions. Okay. Yeah.
Okay, fine. Continuity.
Yeah.
All three.
Yeah. I mean, I'm not punishing you or being nasty. It's just that we need to be remembering this stuff, right?
Could you like before it tells us if it's not this really have limits or derivatives?
No.
No.
It was that Friday, you said?
We have a quiz Friday on implicit differentiation, which we're going to start going over right now. Okay. Okay. So this is in Unit 3, and I believe I've already uploaded those notes for you.
I think that's what we work right. I think that's where the outside consent was. Unit 3 in this class.
Might have been. Let me just pull them up here.
Could be really easy. Alright.
Yeah. So we're going to start in lesson 3.3. 3.3. Yeah, I don't know why I can't find my. I don't know why. Okay, let me try it again here. Did I give you the Unit 3 notes?
We have Unit 3 now.
We have.
Okay.
We've already written on like the first lesson.
It died on 70%.
You sure it didn't just turn off?
No, it does this.
Okay.
I don't think it's supposed to do that.
Thank you, Sarson.
Just thought I'd add.
Thanks for your input.
I didn't know if you do that.
Thank you. I didn't know my iPad did this. Yeah.
When I got back, I had 200. Yeah. 200. I just clicked through it.
I just cleared them out on my phone.
Y'all very regular.
Okay. So implicit differentiation. Okay. Implicit differentiation is used when we have a function that we cannot isolate the variable on. So, or that's difficult to isolate the variable. So for instance, okay, if you look at this particular equation, right, if I wanted to isolate the y, it's a little bit challenging, right? I can move the x over, but then it's in a weird form. So when you see that you have both those x and y's like that, and it's not just a simple y equals something, 99% of the time we're going to use implicit differentiation, okay? Even if it is one that you don't have to use implicit differentiation, it will still work, okay? And implicit differentiation really is not that hard. It's just a matter of remembering some notation. So for instance, okay, let's look at this example 1. It's on page 7 of your Unit 3 notes, okay? Find dy dx. So we're going to take the derivative of this function xy plus y equals 8, okay? So in order to take the derivative of this, okay, I'm not going to try, right, to find dy dx. Typically we would have the y by itself, and then you take the derivative, it's dy dx equals 3, right? So in this case, though, the y is not by itself, and it's kind of a pain in the neck to move it and put it by itself. So we're just going to take the derivative right where it is right now. So we're going to start with this. This is a product, so we have to do the product rule. So first times the derivative of y, of the second, plus the second, times the derivative of the first. Okay, so that's the xy plus derivative of y, so plus dy equals the derivative of 8. I'm just going to write it out like that for now. Okay. Okay. So here's where the only difference when we're doing implicit differentiation is that we have to be more careful with our notation. All right. So instead of just saying dy, it's actually the derivative of y with respect to x. Now this is just y. So the derivative of y we think of as what? What's the derivative of y? 1. So it's 1 dy dx. Okay. Plus y. Now the derivative of x is 1 dx dx, the derivative of x with respect to x, plus the derivative of y, which again is 1 dy dx, equals the derivative of 8 is 0. So now we have x dy dx plus y dx dx, but dx dx is actually 1. So that's y plus dy dx equals 0. Okay. We're trying to solve for dy dx. So now I'm going to move some things around. So I have x dy dx, right? I'm going to subtract y from both sides to get the y out of there. So plus dy dx equals negative y. Any ideas what I can do now to get the dy dx by itself? No. I don't want to divide by x because the second dy dx does not have an x there. I can factor a dy dx out, and what's that leave me with? X plus 1. Okay. And then what? Yeah, so dy dx equals negative y divided by x plus 1. There's my dy dx. Now I'm going to evaluate this at the point 3, 2. So it equals negative 2 over 3 plus 1, which is negative 2 over 4, or negative 1/2. Okay. So I took the derivative just like I've already learned. I just have to be more careful about the notation because we haven't been worrying about that too much. Okay. Let's do the next one. I have to erase some of this. I'm sorry. Oh, actually, maybe I can just make it smaller. There we go. Okay, so we're going to do it again. All right, so we're differentiating. Now, what's the derivative of x? It's 1 dx dx. Okay? The derivative of x with respect to x. Plus, now we've got a product rule. So this is going to be the first, so 3x times the second, the derivative of the x. Yeah, dy dx. The first times the derivative of the second plus the second, so y. What's the derivative of 3x? 3 dx dx. For now, we're going to keep writing the dx dx. We'll let it drop out later. Okay, minus, now we're going to do the derivative of 2y squared. So it's 4y. The derivative of 2y squared is 4y. dy dx equals, the derivative of 2 is 0.
dx. Why don't you do 4 dy over dx? Like, why there's 2 y's?
Because the derivative of 2y squared is 4y.
I just don't understand the dy over the dx. Wouldn't it just be negative 4y over dx?
Okay, so
Oh, she's just doing it for me.
think of it as a chain rule, right? So it's 4u du, but the u in this case is y. I'm sorry, du dx rather. But the u is a y. It just so happens that the dy dx, how do I explain this? I think I'm complicating it. Okay, let me think how I can explain this. This is one of those intuitive things that's really hard to explain.
Yeah, I know, like, for the other one, like, if it was just the 0, and, like, for the 3, you just did 3x, you did 3x dx.
Right.
over
So
dx.
if it was 2 y plus 1 squared, right? So if we were doing that, it would be 4 y plus 1 to the first times the derivative of y plus 1, right? But the derivative of y plus 1 is just 1, right? Well, this wouldn't actually be the derivative of y, it would be derivative of y plus 1 with respect to x. So it's actually just 1, but we need to keep the dy dx there because that's what we're trying to solve for. It doesn't disappear, it just happens that the coefficient in front of it is a 1, okay? Okay, so let's see. So we have 1 dx dx. So now I can let the dx dx drop out. Plus 3x dy dx plus 3y dx dx minus 4y dy dx equals 0. So when we're doing implicit differentiation, we have to put the dy dx and the dx dx in there. Okay? Okay, so now we're trying to solve for dy dx at the point 1, 1. So I've got 3x dy dx. I'm going to get my dy dx's all on one side. Minus 4y dy dx. I'm going to move anything that's not dy dx to the other side. Okay, so that's going to be equals negative 1 minus 3y. We're taking the derivative the same way, it's just we have to add the notation in there. I'm trying to get that dy dx by itself. So dy dx, I'm going to factor that out, 3x minus 4y equals negative 1 minus 3y. Dy dx equals negative 1 minus 3y over 3x minus 4y.
So why do you have to do that? Just for the AP test, like just to notate it differently, or is it like why do you have to do it that way?
Because that indicates that we're taking the derivative of y. Since there's both an x and a y in there,
Okay.
I have to indicate what I'm actually taking the derivative of. Okay, so that is just like when we're talking about functions. F of x means I'm taking the function of x, not the function of y. So this tells me that I'm taking the derivative of y with respect to x. That notation indicates that the y is the dependent variable, right? So it's the slope is going to be depending on its rise over run, right? So it pulls all of that together for me, okay? Now I'm doing this at the point 1, 1. So this is going to be negative 1 minus 3 times 1 over 3 times 1 minus 4 times 1. So we get negative 4 over 3 minus 4, negative 1. So we get 4. Okay. Now, if I were able to isolate or rearrange this formula, it can be done. It's just a lot of work. If I could write the formula as y equals something, right? Then when I graph it at the 0.11, okay, I don't know what's happening. I might be doing something weird like this, right? At the 0.11, something like this, it's going to have a tangent line with a slope of 4. Okay, let me just say that again. If I could rearrange this equation to be y equals something and then graph it. Okay, if I rearrange that equation to be y equals something and then graph it, when I graph it, at the 0.11, the slope of that tangent line is 4. That's what we just figured out. Up until now, we've been working with the equations that were in this form, or could easily be put in that form. Now we're working with an equation x plus 3xy minus 2y squared. I cannot easily put that in that form. Right? So because of that, in order to figure out the slope of that tangent line, I have to use implicit differentiation. But I'm still finding dy dx. dy dx is giving me the slope of the tangent line at that point. This is a really important connection to make. Okay? What we've been doing before, when we had things like y equals 3x minus 2 over x squared plus 5, right? And you were asked to find the derivative. You were finding dy dx, the derivative of y with respect to x, right? And you were getting some, let's say at x equals 2. You were getting some number. This was giving us the slope of the tangent line at this point for that equation. Now we're dealing with equations that we cannot easily put in that form. So we're using implicit differentiation. The implicit differentiation is still giving us dy dx. It's still giving us the equation of the slope of the tangent line or the slope of the tangent line. We just have to use a different method because the equation's not being put in a nice, pretty form for us. Okay?
Maybe they should just give us in complete form.
Okay, let's look at number 3. We're asked to find dy dx again. Okay? But this is a really ugly looking equation. So we have to use implicit differentiation. Okay. Taking the derivative of y to the third, what do we get? 3y squared dy dx.
That's just not worth it.
What's the derivative of 5 at y squared? 10y dy dx. What's the derivative of negative 5y? Negative 5 dy dx. Minus, now the derivative of x squared, 2x dx dx. I'm not going to write the dx dx because we know that equals 1. So I'm going to stop writing the dx dx, right? Equals, what's the derivative of negative 4? 0. Anything that does not have a dy dx, I'm going to move to the other side. So we're going to add 2x to both sides. So we have 2x over there. Okay, so I moved this to the other side. Okay, now on the left side, what am I going to do? Factor a dy dx out, yeah. And that leaves us with 3y squared plus 10y minus 5. I'm going to divide. I need to get dy dx by itself. So it's 2x divided by 3y squared plus 10y minus 5. Okay, now, so what we're doing here, we have this equation, and we're being asked to find the equation of the slope of the tangent line. And that's our answer right there. This problem, it did not tell me at a given point. So that's the equation of the slope of the tangent line, and it's going to vary depending on what x value we have. Okay?
Why was that one easier than the others?
Because you just have more understanding, but also because we didn't have to do the extra step.
Oh, the points.
Yeah.
That makes sense.
Okay, here's another one. Find y prime. Now this time they're not specifically telling us that we have to do implicit differentiation. How do I know I have to?
Because of the y.
Because I have a y and an x on the same side that I cannot easily isolate. Okay? Now, we could do this. Well, in fact, maybe we'll do it both ways, and hopefully it'll come out to be the right answer. I hate it when I randomly do that because then that doesn't work out. Let me see here. Okay, let's do it implicit differentiation, right? So y prime is the same thing as dy dx, right? So we're going to do the first times the derivative of the second. So what's the derivative of e to the x? E to the x, dx dx, right? Okay, plus the second times the derivative of the first. What's the derivative of the first? 1 dy dx, yes, equals the derivative of 3 pi, which is 0. Okay, this was a product rule. First times the derivative of the second, plus the second times the derivative of the first. Okay, so we get e to the x dy dx equals negative e to the xy. So I'm going to divide by e to the x. So dy dx equals negative e to the x times y over e to the x, which gives me negative y. That's my y prime. Okay, I'm going to try it the other way. I'm going to isolate the y. Y equals 3 pi over e to the x. Okay, so dy dx equals low d high, derivative of 3 pi is 0, minus high d low, so the derivative of e to the x is e to the x, all over low low. Okay, so we get dy dx equals negative 3 pi e to the x over e to the x squared. So it's more complicated here algebraically. It doesn't look anything similar, does it? But look what's going on, right? Okay, so first off, this is going to be negative 3 pi over e to the x. Well, did I get the same answer? No? Well, look up here. What does y equal? 3 pi over e to the x. So what did we get here? Negative y. Well, this is negative 3 pi over e to the x. So they are the same answer. But this was a lot more complicated to do than the implicit differentiation.
Yeah, that was all.
Okay? I will tell you, however, on your AP exam, sometimes a multiple choice question will give you something like this, right? And you do this, but the multiple choice selections are in that form. You have to at least understand that they're the same. Okay? Okay. Ew, ew, ew. Ew, 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 ew. 126. Okay. Okay, here we go. Let's do this. So we're differentiating. So taking the derivative of cosine xy. So I'm going to say let u equal xy. Right, so I'm going to think of this as cosine u plus equals x plus 3y, right? So du, that's going to be the first times the derivative of the second plus the second times the derivative of the first, right? Du dx, okay? So we're looking at the derivative of cosine u, which is negative sine u du dx. The derivative of cosine u is negative sine u du dx. This equals, what's the derivative of x? 1 plus the derivative of 3y? 3. Good. 3 dy dx. Okay. Now we just have to change this u stuff. Negative sine u, so xy, times du x dy dx plus y. This is nasty.
Oh, you
wow.
did the product.
Yeah. Okay, somehow we've got to get that dy dx by itself.
Where did the other x
This x right here,
come from? Yeah.
that came from the derivative of u. First times the derivative of the second, plus the second times the derivative of the first. Okay, so we have negative x sine xy dy dx minus y sine xy is 1 plus 3 dy dx. I need to get that dy dx all to one side. So I'm going to I'm going to add this term to both sides. Okay, so I have negative y sine xy equals 3 dy dx plus x sine xy dy dx. Oh my goodness. Then I'm going to subtract 1 from both sides. So I have negative 1 minus sine y sine xy blah blah blah. Okay. So we have negative 1 minus y sine xy equals, we're going to take a dy dx out. Leaves me with 3 plus x sine xy. What am I going to do with that? Trying to get dy dx. Divide, yes. So we end up with negative 1 minus y sine xy divided by 3 plus x sine xy equals dy dx. And we're finished.
That's great.
That was crazy. That was nasty. Really nasty.
I know.
Okay, listen, you just have to keep plugging through. Don't stop. Just keep pushing forward with it. Okay. Okay. For homework, I would like you to do homework number 3.3. Right, 3.3. Numbers 1 to 4 only. Okay, numbers 1 to 4 only. Okay. Numbers 1 to 4 only. If you are struggling to keep up, you need to come see me for extra help. Okay, we have to keep pushing along. So you need to come see me. That last one was pretty rough. Don't panic over that one, but the others you should be able to do.
I got that one. We can get the other
See,
ones.
those are fine, but then we have to go